presentation, we will discuss the workflow associated with underground timing, from the prerequisites through to the timing. We'll also discuss the ways to update the mine plan after it's been created. For this presentation, I will be using Carlson 2010 running on AutoCAD Map 2009. Carlson 2010 was developed to run on all versions of AutoCAD Map or AutoCAD from release 2000 up to and including 2010. It also runs on IntelliCAD version 6.4 and 6.5. Today I am running on Windows XP Pro, but we also run on 32-bit and 64-bit versions of Microsoft Vista. We have here the underground planning workflow diagram, which is a little hard to read in this resolution, but it's fairly straightforward. We have prerequisites for the line work in the drawing. Draw the perimeters of the panels on the brim layer and pillars on the pillars layer. We have the options here for the geologic input of the grids. We place the panels in phase 1. We use the timing project manager in phase 1, and we fill out those input requirements. Then we go into phase 2. Now phase 2 is just mainly optional tools that we can use to tweak the mine plan to make the sequence work out better, or to edit the information in the panels to make them reflect what we want to encounter in the mine plan. Then we take this information and we run the underground timing, where we assign the panels to be mined to the equipment in the sequence we want to mine. We kick out reports, and after the mine plan's been created, sometime in the future, say 3 to 6 months or whatever time has passed, you can then set a new start point for your mine plan, new start date, and rerun it again and generate new reports there. In the prerequisite phase of planning, at this point we'll talk about line work requirements. The line work must be on special layers. The pillars go on the pillars layer. The panel perimeters go on the brim layer as closed polylines. If you're not placing your panels by text, this is the only prerequisite that you have for line work. If you are going to place your panels by text, use the auto place panel by text method. Then in addition to the line work, we can input some of our planning assumptions by just simply placing the text inside the panels on special reserved layers. Then when we use auto place panel by text, the data will automatically be tagged to the panels. The name of the panel can be brought in on the panel NM layer. The extraction rate is automatically calculated if the pillars are drawn. But if pillars are not drawn and we're only using the panel perimeters, we can input the extraction ratio for both advanced retreat mining by using the extraction and RET_extract layers. We can also input difficulty factors, which we will talk about later in the presentation. Here's a graphic illustration of line work requirements. The perimeter, as you see in the magenta line outlining the panel, is drawn on the rib line, and at the front side of the panel, or the beginning side, it's usually drawn flush across the back of the pillars, and then on the far end, it usually has the full width of the entry all around it on all 3 sides, but it's usually flush at the beginning. We can plan, or we can do our calculations with the pillars drawn. The program will automatically sum the areas of the pillars and subtract it from the area of the perimeter of the mining on the brim layer, and calculate the extraction ratio for us. If we automatically draw this using advanced projections, then there will be another layer created not a requirement. We do have the option of planning without drawing the pillars, and we can just literally draw the panel perimeters on the perim layer, and then put a piece of text in here and use auto place panel by text, and it would be equivalent to having the pillars drawn. If this were a surface mine geologic model, it would be composed of the elevation grids and the topography grid, and they'd be stacked up together for all strata from the surface to the lowest coal seam. But when we work with the geologic model for an underground mine, we only need the thickness grids of the clean coal and the thickness grids of the rock. Now, these grids will be composited thickness grids. In the case of the clean coal, it'll be all the splits of the coal summed together, and in the case of the rock, it'll be some of the partings taken together with any out-of-seam formation. And that'll be based on drill hole data, of course. The density units can be gridded, or the density values can be gridded in a vary across the property, or you can take an average. The units for that in the metric system are kilogram per cubic meter, and in imperial they would be pounds per cubic foot. Quality grids for other attributes found in drill hole data can be linked to the mine plan to facilitate quality forecasting. In phase one of mine planning, when we get into the timing project manager, this is the area where you give your project a name, input the start date and the number of shifts per day. You define the equipment production rate of your continuous miners and your longwall equipment. Define the operating calendar after defining the equipment production rates, and then you define attribute groups, which are panel types. For example, you've got longwall development headings versus main headings versus longwalls. You can link different sets of thickness grids to these to reflect the type of mining you're going to do, and also link different difficulty grids, for example, to have different production rate throttling aspects to these different panel types. And there's also the option where you can identify delays by placing text in your drawing, refer to those as drawing events, and or you can also add calendar events which are input at the time when you sequence and schedule your mine in the mine timing. When we place the panels, we're going to place them with one or more of three options. We can place them all with any one of these, or we can combine these methods when we place the panel. The place panel method was the original method that we placed panels with. Auto place panels by text is another method that allows us to pick up some of the data that we would have had to key in by just placing text inside the panel outlines. Pick and place is another method that can be used for detailed mine planning. The first phase one steps that we'll take here will have to do with looking at the underground project manager, the timing project manager that is. And we'll walk down through here and we'll look at the options that we see here. Under settings, we see we have drawing event types, calendar event types. If I pick on the drawing event types and edit, I can see that there are overcast and bellhead options put in here, and I can edit these. And I can see that these were defined as OC, the capture layer was overcast, the description is overcast, and the event delay is going to take 3 shifts. I could have under these taking down additional units. For example, when you make longwall moves, sometimes you may borrow people from continuous miner units, and you can also include those people as down also. Besides drawing event types, there could be calendar event types. And calendar event types just typically work with the unit in question because they're added when you run the mine timing and you schedule the event between two panels. When we define equipment, we can edit set. The set name is Flex 1, and if I edit the equipment, I can see that we can schedule the, you give it a name, we can schedule the equipment in tons, and if your drawing's metric, that'll be metric tons. Distance is typically used for a long wall, cubic yards is used for surface mining, and linear. In a metric drawing, this would be linear meters in advance. And you would indicate, in this case, how many feet of advance you have, and how many hours of shift you work. And if you make an adjustment here, or you change a number, say you change this to 9 hours a day for a shift, or 9 hours per shift, right, then this number will change. Whereas if it kind of back calculates, but allows you to make adjustments in these numbers. There are options here to indicate the rate per hour and also indicate an availability. I don't typically use this for underground mining. The advance minimum mining height and the retreat minimum mining height means that if you have a piece of equipment that's thinner than the coal seam, you can take additional rock to get the clearance you need, and it will be calculated automatically if you put a minimum mining height in. If you have a maximum mining height, then the program will automatically leave additional coal that cannot be reached. There's a few places in the United States, and the Pittsburgh seam that take advantage of that. The main main maintenance frequency and routine maintenance frequencies are options for allowing you to schedule downtime in the same units that you produce in. So that if you want to say every 10,000 tons or 15,000 tons, you're going to take a day or shift down to do repairs, you can do that. It's not commonly done like this. Extraction factor was designed for twin bore miners to convert their oval shape to a rectangle. There's a few pieces of equipment like this still operating in the United States. Under the advanced options, there's the opportunity to specify a difficulty factor based on date range. And this would be the ending date, and this would be the difficulty factor. The difficulty factor throttles what I refer to as the sunny day production rate, so that your effective productivity is your stated rate in the previous dialog box here, divided by the difficulty factor, this date range, and that will yield the effective productivity when you go to schedule. The difficulty factors and the things that throttle productivity for coal mines typically fall into amps. One is date related, time related. The other is positionally related, such as areas where there's difficult mining conditions, bad root, water, whatever. Those can be identified and gridded, and taken care of that way. But you can also identify areas where difficulty could possibly be based on the thickness of the clean coal, and you can indicate difficulty based on thickness ranges here. For surface mining, we can also identify related difficulty factors here. This is typically used for commissioning curves. We refer to them as learning curves in the U.S., where you're starting up an operation and you start up at low productivity and you hope to get to your standard productivity here, but it may take a month or two in order to get up to that point. So this is how we would set about finding the equipment in OK. And in this example, I've got two continuous miner units running. You typically want to put as many units and maybe even a spare on this list, because you need to create your equipment list first, then come down to calendars next. Have more than one calendar. And in this situation, we're going to apply the calendar to all the entities on the list that we have. And the way the calendar works, it's like writing a sentence. You pick the year, the month, the day, and based on that, the program will allow you to schedule for all the entities or all the equipment or selected pieces of equipment. If you wanted to have an individual independent schedule for the second miner unit, for example, and you wanted every Saturday to be down, or maybe one shift. We went to January and we said from January 3rd we wanted to have every other Saturday only work one shift. Then we could say we just want the second shift to be scheduled down, and this can be once, daily, weekly, monthly by weekday, monthly by date, quarterly, yearly, yearly by weekday, or every. We can indicate now every 14 days, every other week, for an indefinite period of time. We're going to schedule a second shift down. We can say that this is some form of attendance. Apply, and now from now on, that will be down every other Saturday. And if we come over to May, you'll see that every other Saturday we are working one shift, but we're down one shift. And then the alternate Saturdays, we're not working at all. In this case, we'll work 2 shifts a day. That is how you set about defining your calendar. It's very easy, very straightforward. Okay. Your timing assignment is created when you run the timing. So this generally is not generated here, but it kind of feeds back or lets you know what panels have been assigned based on your timing. Likewise, any panels that have been placed are listed here, but they're not generated here. And the attribute groups, on the other hand, are generated here. And the default is always going to be an option, but these were created additionally. And if I pick on this, I can see that the thickness is the thickness of the clean coal, the density is the density of the rock, it's the density of the coal. If I had rock thickness and rock dense, those variables would represent what's going on with the rock. In this particular case, there is a rock thick variable that goes out and links to a grid. This is the path name to the grid. And there's a difficulty grid that goes out and links to access databases and pull the data in from the access database to create royalty reports and things like that. So and the first thing you normally do when you come in is you set the mine start date, pick it off the calendar, click on this button, and indicate the numbers just per day. You'll need to do that as soon as you come in. And this is the mine timing project panel. I'd like to discuss some of the phase 1 options and processes that you go through, primarily in placing panels. Under the underground drop down, we have place panel, pick and place, and auto place panel by text. And I'll just very quickly go through the process of placing a panel and then also show you the auto place panel by text. Pick and place takes a little more time to set up, so I'll just go easy examples up front. Place panel. At the command line, we'll get the option to use quick place mode, yes or no, and I usually decline this option. Starting mine plan, I'm going to say yes. Mine plan is just a list of panels. Enter or pick the mine entrance XY location. In this situation, I normally snap to, you could snap to the center of the panel here. If it's drawn with the advanced projections, then you use the endpoint option. Then I normally snap to the perpendicular of the back side of the panel. Then I pick inside. You're given these options, your attribute group, which you can find yourself as far as any type of panel. You do have to give the panel a name. In this case, I'll call it 10 names. You can give it a panel start date if you'd like to, if you're going to hold the panel up or delay it from starting. If you do, you can use the calendar that's tucked up underneath this button. If I click on this button, I'll see a calendar here. The easting and northern coordinates are automatically generated from the points you picked. The entry width in English units would be around 20 feet. In a metric drawing, it might be 5 to 6 meters wide. The extraction ratio, notice, is automatically calculated. The sum of the area of the pillars drawn, or the pillars layering, the rows model. In this example, are subtracted from the area of the perimeter and generating the extraction ratio. We're not going to prompt for cold qualities or treat options just yet. We can set precedents in here if there were other panels that had to be done first. I'm just going to hit OK at this point. And we notice that we are attached to the end of the panel here. We wanted to bend this panel slightly and keep the name the same. We could. Most of the time, you're going to see that when you get to the end of the panel, if you turn in any direction, you're going to change the name. I'm just going to hit enter. That's the process for place panel. If I were going to continue to place in these panels, attaching to the original one, I'm still in the command that says select and enter your branch front, pick a point on the backbone line, and then you work into the panel you're going to attach, pick inside the panel, and back here again. So if I say the name of this panel is 1 underscore right, I don't have to use underscores. There can be gaps in the name. I can just accept that, go on, right click, and I'm done. This is the original way that we used to place panels. there's a quicker way, and it's called auto place panel by text. It has a prerequisite where you have to have the text pointed in the direction that you have in mind on the layer panel NM, which I have in this case. The line work for the perimeter is in the perimeter layer, so I have the line work prerequisite set up. All I have to do at this point is go to underground auto place panel by text. Now there's some prompts. It says assign 0 retreat extraction ratio in this case. I'll say yes. Enter. Advanced difficulty factor defaults to 1. I'll accept that. 1 means that there is no difficulty. Entry width, again, this is an imperial exercise, so it'll be in 20. For the entry width, select the objects. So now, if I just select these objects, hit enter, they all get placed automatically. Notice there's a slight difference here. When you place a panel, use the place panel, get this red lead, which automatically determines a precedence so that this panel must be mined before this one can. When you place panels using auto place panel by text, these panels are placed as a group, but there's no precedence between them, so you'll have to enforce the precedence with your sequence, or you can also define the precedence when you go into, for example, a phase 2 option would be to go to underground edit panel, and if you pick on one of these, you'll see that the extraction ratio has been calculated again. If we want to set a precedence in here, we can screen pick and say that this panel cannot be mined until this one's mined. Just picking in there will select that, and it didn't select it in this case. And the reason is that that panel is on a different list, a different mine plan. So the way we would take care of that, cancel here, is we'll go to the underground connect mine plans option here, and we'll pick this one and then pick this one. Now all of these were placed at the same time. They'll be on the same mine plan originally. This one and this one were on the same mine plan originally, but now these two sets of plans are joined together. So if I go back to edit panel, I pick on here and edit this list, that should have brought them all up. So I'm going to clear this and screen pick, and this should pick, enter. We're still not seeing it. So I'll have to check out that. This is the edit panel option. These are the features that you can have, and I'll have to check this connection on the mine plans, underground mine plans, here, here. Alright, let's try it one more time. Underground panel. I can pick any of these at this point, and I should be able to screen pick and pick here, enter. Now the plans are connected, and they should I should be able to see the full list: 1 right, 2 right, and northwest mains, north mains. Okay, and here. Let's see if these got placed. So I'm going to hit edit. Here it is 4 right, and if I screen pick for precedence, pick over here, enter. Not sure why. Oh, 2 right. talk about referring to edit panel attributes, reset panel attributes, and set attribute by grid file, we're talking about linking these attributes to the geologic model primarily, or to difficulty factors and things like that. And these are options that we have for modifying the linkages that we've already established. If we are using the auto place panel by text, and if we are using extraction rates or ratios that have been input by text, then we have to use this option to link the text value to the mine plan. Under scheduling options, we have ways of tweaking the scheduling options and opportunities, such as we can subdivide the panel into some equal number of parts, which is seldom used. Rather, we normally use the add and remove endpoints, so we can set custom stopping points along the development of the panel in case we wanted to turn off to the left or right, or stop at a certain point and then come back to that point later and continue. When we disconnect the mine plans, what we're saying is that a mine plan, according to the terminology and definition that we use in this workflow, is a list of panels to be mined. And sometimes you cannot place your entire list to be mined at one time, so you have to place a certain number of them, and when they're placed together they become a mine plan, and you can connect different lists together, and also you can disconnect panels from a mine plan. You can also remove a panel which is recommended to use the panel to clean out the database before the line work is erased. This particular drawing was used in 2009 Carlson Software Users Group session on advanced mine finding. While it's not a particularly large mine layout, it does have some interesting features that will allow me to discuss some of the phase 2 options and the way we went about setting the mine up. If I pick on here, I can show you that the mine was laid out using the auto place panel by text, but then we had two boundaries, in this case for perimeters. This perimeter was used on each section for advanced mining with a separate extraction ratio from this panel, where we had a combination of driving rooms on the right hand side and then recovering pillars in the center of the panel. And in doing so, we would schedule this to drive up on that outline and back on this one, and did that for each panel. These green double circles are what we refer to as pinpoints, and they're found under the underground add pinpoint and remove pinpoint, and they will subdivide a panel so that you can stop at that particular point and come back in and start again in your schedule. If I were to pick on this panel and edit the panel, I would see that the panel name refers to the entire panel. However, when I go to time this, you'll notice that this name also has a suffix, B to 1, 1 to 2, 2 to 3, until it gets to the end, which is represented by an E. You'll see that when we go to the timing. In addition, we included drawing events in this area to represent the placement of belt heads and overcast ventilation controls in this particular area to show their impact on productivity. So in order to show you that, I will turn on the layers for the belt head and layers for the overcast. And here you'll see that these are just pieces of text that represent the number of overcasts that will be placed here and the location of the belt heads. And if I turn on the pillars, you'll be able to see how they fit in. The pillars were drawn using the advanced projections under the works drop down right here. I'll show you how easy that was to do here in just a second. But at this point, these are drawing events, and they were created under the timing manager, under the settings, drawing event types. You can see again, overcast and belt head right here. In addition to that, I'm going to turn the pillars off at this point. I'm going to go to View, Freeze Layer. We also have difficult mining areas in here. And if we go to the difficulty layer, it's listed in here as the hazard layer. And at this point, if I show you this, the bad roof area has a difficulty in here of 1.75. This is an inclusion perimeter, and a grid was made. Originally, the grid had values of 1 throughout this area, but inside these inclusion perimeters, we set the value up to 1.75 to represent the difficulty posed by bad roof here. And in this case, where a stream channel came together, we set the difficulty up to 1.5. That will slow mining down in these areas based on what they would normally do. They'll be divided by either 1.5 or 1.75 in those cases. In addition to this, we also can divide the area up by property boundary and then report out the production by property owner. Of course, in the case, with Coal India owning it, it's probably not relevant at this point. But we often have to deal with different property boundaries and report tonnages coming off of each boundary for royalty reports here in the United States. If we were to run this mine timing, we can take advantage of all these tweaks, and we'll do that in the next video. The process in phase 3 of the workflow is very straightforward. We do the mine timing, we select the equipment from a list. We assign the panels to be mined to the equipment in the sequence for each unit to mine. Delays can be inserted as calendar events between the scheduled panels to represent delays, for example, unit moves between panels and things like that. This process is very straightforward. We'll discuss the actual mine timing in this discussion, and the way we'll go about that is we'll leave what we have on the screen here, zoom in a little bit. I'll go to underground timing, pick on the backbone line. It's all connected up as one mine plan. The different areas were connected together after they were placed. Most of the time we can place them in one group, but I believe these mains were placed using the place panel, and then the offshoots, the panels off to the left and right here, were placed using our place panel like text. If we pick on the green backbone line and we accept these start dates, we hit OK, we'll see when we go to do the mine timing that we have different units here. I'm going to remove the longwall unit. I don't think I'm going to be using that, but in fact I think I'm going to have to import the timing, load the timing here from Lexform. That up. And now what we will see is work that's been laid out before. We have all of our panels were originally over here under the unassigned, and then I just literally picked on the unit and picked on the panel names over here, or I can screen pick and assign it that way. So for example, if I wanted to remove the northwest mains, go back across, and then if I knew where the northwest mains was, I could go screen pick, just literally pick right there, hit enter, and it would have been put right back in there. Now it's probably down here at the bottom, and so I'm going to remove it again, and I'm going to pick up here and just assign it that way so that it goes in near the top, and I can say earlier, push it up that way. Now if I had a delay, a calendar delay that I wanted to put in between for section move, for example, I could pick in here and say add a delay, and I can say maybe it's due to a belt hit and indicate the delay that I want. 52-day delay, where I set the belt in, and I can set those delays in calendar days, which include Saturdays and Sundays, or as scheduled days, where if you didn't work Sunday, then it would not be counted as part of that delay. Bridge over to the next day and count that. Okay. So at this point, you can put delays in anywhere you'd like to better redefine your mine plan. We've got the starting date and shifts brought across from the timing project manager. Bottleneck parameters don't typically apply here. This is set up for surface mine. Hit calculate. And we've got two reporting outputs here. We have a report and a detailed report. The standard report will run and tell us, for example, if there's any day to give us kind of a Gantt chart feeder for information here for scheduling, and any information that's over here can be pushed across. We can also kick it out to an ASCII text file right here, and we can can see, looking down through here, that there are no days waiting on this particular schedule. And there may have been around here on some at the bottom of that, but basically everything is running. It's called the mining progress report. Now, I'm going to exit here, come back into the timing. Because I ran the standard report, I have to calculate again before I run the detailed report. Now if I run the detailed report, I get a dialog box that allows me to define everything that I want to see on the mind map as far as the way I time it out. I can enforce custom colors and set the dates and color the different date ranges up. I can have constant date periods here, or I can have variable periods. So if I wanted to go from weeks to months to quarters to years, I can do that just by setting the date. Just changes. Go right in and change the date right here. Or I can auto set the date, and I can say starting on line 1, I can set the starting date here at 3/1/2009 and go yearly for 25 years. And notice I've got options there. I can go by different amounts and hit OK. And now, if I don't particularly like a color because it's too dark, pick on the color and change the color, set it up any way I like. Okay. And if you don't want solids in here, you want some other patch pattern, for example, put that in there. There's many options that you can use in setting up your maps. Since we enforce the custom colors and set the date table, I'm going to use the custom date table here. We're going to start at 3/1/2009. The program will tell you how long your plan will run for. And if you don't want to see the plan that far out, you can truncate it just by setting a shorter date in there. You can also indicate you want to start a later date. Even though the program is going to start this date, it'll only show you that band of operation between the dates. And now the retreat patching will be reflected by an angle patch pattern. And we'll go ahead and run the timing. Notice that I want to see if I can move this out of the way. Presentation. And you can see the software timing up the different years. Both advanced and retreat mining. And now here's the map that was created, timing on it. Now we can generate the reports that can go out to Excel. So at this point, any information that's available over here can be brought across, and we can create reports here. Now, we can pick any kind of format and save it based on layouts we've done before. And if I like this, I can give it another name right here and hit the save button. It'll go back on the list to be picked from right here. So this is how we get the different reports on here. And then if I want any other, say I want the equipment, for example, I want to add that, move it up. Or if I want it underneath of the period, I can do that. And I usually don't sort the period, it'll come out in its natural order. And I don't really need to sort most of this information below here. And I can subtotal this export to Excel options are right here. The report options are here, and I can put them out to different file formats. I can export this to XML, text, an Excel database, Access database, and DBC, or just pump it out to a spreadsheet and include the totals and hit OK. And now here's the report, and this tells me that for these periods that this is the equipment that was operating, and here's the panel names that they were in, area, total tons, rock tons, total tons, key thickness. Key for us means clean coal thickness. And the bolded lines indicate that it's a total for that period. See, now these reports can be formatted in many different ways. This was reported out with period first and then equipment. But I can close this out. And I can come back and say, well, maybe I want the equipment first. And I want it subtotal by equipment and then period. I can hit export to Excel. Pop it in there, and here's the report sorted by equipment, and then period, showing the panel, and then total by period as it comes down. So you've got quite a bit of flexibility in getting your timing reports created. So that's a snapshot of what's involved in doing the timing. And thank you for your time. Oh, excuse me. One other thing I wanted to show you, the actual timing here and the text is put in. On the advance, here's the equipment, date range, referred to it. There's a lot of control that you have over this text also in your put it perpendicular to the green backbone line or parallel to it, and you can put different data in there also. If we go back and run this report, one thing I did not add in the report was the difficulty factor. If I clear the timing report, let me just go ahead and clear the timing report. So I'm going to go underground, clear timing report, and coloring for both the advance and the green. If I hit B and hit enter, enter, select the objects, enter. Okay, we might have found a bug in 2010, so I'm going to go ahead and press ahead. If I go underground, timing, and then pick on one of the green backbone lines, right, and hit OK. And if I run the timing calculated again, the detailed report, okay, it will overwrite what it had before, but everything's going to be in the same place. This is a beta version of 2010. It's just come out and hasn't been totally debugged yet, so the clear timing report might still have a little hiccup in it. What I wanted to show you here is if I didn't save this last time, so what I wanted to show you is over here on this side, there's an option to bring the difficulty factor what's going on. I probably won't need the area here. And if I want to look at the tons per shift right here. The tons per shift next to the difficulty factor should give you an indication of what's going on here. And if I say grand period, up and up to Excel, okay, Excel, here's the difficulty factor of 1 in the tons per shift. And now if I drop down to areas where we're picking up the difficulty, you'll see as we go through some of the productivity will drop somewhat. Now, because we're on the annual periods, we're seeing things are barely being affected here. If I were to change that to monthly periods, then we'd see a much larger impact. So if I were to calculate this one more time, detailed report, set my dates and colors, find the period, clear that, auto set, and if I start from 3/1/2010, now these dates can be set to read day, month, year also. But if I indicate that it's going to be monthly by date for 20 years, hit OK, and hit OK here, and then hit OK. Now you're going to see a monthly timing, and now you'll see the impact of the difficulty is greater. It'll also take a little longer to run. Okay, now if we take the difficulty factor, I should save that report. But pick up the difficulty factor, and then and there. And now I can set this to where I don't have to do this again. All I have to do is save this when I get it where I want it. Right there, I won't have to do that again. And I come in here and say I want it by period. And again, if I just save that, it will move forward. So, look it out. Now I should see, if I come down through here, some 1 point numbers a little higher than that. I should probably see some. Well, they'll still be way average when they cross the zones. Weight average. And I think there could be something I have to check on that. But this is the 2010. It's been out for about a week now, and a little over a week possibly, and we're still putting it through its paces. Upon running the timing calculation, we have several report formatting options that we generate. One of them being the standard report, which points out scheduling conflicts and panel waiting times. We also have the detailed report, which leads us to design the colored timing map options, where we can break the map down into timing periods such as a week, a month, quarter, or year, and we can time any date range that we like. quality forecast in them. And we can export these to several different file formats, including ASCII text files, access databases, Excel spreadsheets, XML data format reports, and other ODBC databases. Fine plans, by their very nature, are fractal creations subject to variances. While these variances could be positive or negative, it just seems most tend to be negative. But whether after 3 to 6 months you're ahead or lagging your objective, if you're not exactly where you forecasted you would be, the difference could affect your quality. To update your plan, you will need to update the location